Hello everyone, welcome back to our Principal Software Engineer channel. Today we're gonna start our journey into this first CSAPP project. The name is called datalab. Before we get down to the coding part, let's first spend a couple minutes to get familiar with the tools provided by this project. To do this project, we need to prepare for three things. First, we need to download the source code from the official website of CSAPP. Then we're gonna use a terminal to do the programming. And then we also need to learn about the tools and executables provided by the project in order to test our code. I'm going to show you how to do this now. To get to their official website, we simply need to Google CSAPP. It's usually ranked top here on Google. So we can click on the link here, and then we need to go to the student sites. And then here there's a link called the Labs for Self-Study Students. Here, this page has all the labs we're gonna do later in this series of video. In this video, we're gonna start with the data lab. To download all the source files and the instruction we need for this project, we just need to click this self-study handout. Once we click that, there will be a tar file downloaded into your computer. And then we can use this follow this instruction here to untar the file, basically extract the contents of the tar file into our local computer here. I already did that. Now let's switch to use the terminal to look at the files and do the programming. Okay, here I have my terminal window open with two screens. Both of them are in the directory where I extracted the datalab handout tar file. So if we list all the files in this directory, we can see there are a bunch of files in it. For this project, the only thing we need to change is this base.c file. Let's try to open it on the right side here. So I'm going to use Vim to open this file. So here, this file has all the in the common section. It has all the instructions, requirements, and limitations we can when we implement the solution. And then below the comments part, then there are the function stubs where it currently has only the signature of the functions and then return a hard-coded fixed value. Obviously, this return value are the wrong one, and then we need to do the implementation here later. So we'll worry about the actual code logic later in our following videos. In this video, again, we're gonna learn how to use the tools provided by the project to test the results of our code changes here. So assume we make some code change here, and we want to test whether this implementation for this function is correct or not. There are two things we're gonna need from the project to test the results. The first thing is exactly this DLC executable. I believe it stands for datalab compiler or datalab checker. So what it does is to check the semantic or syntactic correctness of our solution here. What do I mean by that is, so let's take this for example. This specific function has requirement that we can only use operators of this bit level not or bit level all. In addition, it has this requirement that we can use at most 8 operators in order to do this to implement this logic here. Now, assume if we imagine if we do something super complicated, unnecessarily costly, that we may use more than 8 operators, or if we cheat a little bit, saying we do not use these 2 operators, but we directly use the bit end operator to return the result. Logically, the result will be right, but when we check that with DLC, it will give us the error. So by default, if we only do DLC, it will just, sorry. if we do DLC, we need to provide this file names, which is bits.c. If it doesn't have any error, it won't throw out anything. But if we do have some errors here that violates one of the restrictions, it will tell us what was violated. If we want to see exactly how many operators we are using for each of these method here, we can use this option called -e for the same file. Here it tells us for each of the functions how many operators we are using. So because array function right now is not doing any of the operations, it directly returns a fixed value as the last sentence in the implementation. So array function here has 0 operators, which is expected. Imagine later on we do something complicated here, then this number will be changed. Again, this DLC is for helping us to check the syntactic and semantic kind of correctness of the solution. It doesn't actually check whether the returned result is correct or not. For now, we know for sure this result are not right logically, but it doesn't complain anything here, right? So to test the logical correctness of the solution, we need the second set of toolset, which is defined and provided by this btest.c and btest.h files. So to use that, we need to do first do this make btest. Once we do that, we're going to see a couple of warning errors here, which is expected. We don't need to worry about this. Just ignore this couple of warnings. Once we do this btest here, so if we see try to see again what are the available files, we can see there's a new executable file called btest, which are compiled, which is compiled from this btest.c and btest.h together with our bits.c. What this make btest step does is it takes the file here on this bits.c file, compile that together with a couple of predefined test case defined in this btest.c file. And then these test cases are the ones to help us validate and check our logical correctness of the solutions. So once we compile this, we can run something like a btest without any of the inputs here. By default, it tests all the functions with the predefined test cases. Here you can see every function is failing the test cases. Here, this btsend, this get bytes, these are all the functions here. Currently, they fail because we haven't implemented everything, and it is expected that they are failing. Let's take this btsend for example. So in this case, it's taking this 2 large integers as an input, and then it's expecting another integer like this. But in fact, the test case is getting a result of 1, which is hard-coded here. So these 2 results doesn't match, so it is a reporting error here, right? But later on, when we implement it in the right way, then this error should go away. Another thing about this btest we should get familiar with is it doesn't in addition to test all the cases here, we can also specify which function we want to test by providing this option called -f. Let's say if we want to test specifically just a bitsend, here it will only run test cases for this specific function. Here we see the same error as showing here. It just doesn't run the test for other functions here. This is handy when later on when we are specifically working on a particular function. We don't want to see all the noises from other functions here, other test cases here, so we can test for this specific one. In addition, so if we run in this way or the previous way, essentially they are using predefined test cases. But sometimes when we test some tricky cases, we want to use our own inputs, right? So to do that, the b-test provided additional arguments here we can provide. So the b-test has two inputs. We can use -1 and -2 for the specific inputs. In this case, let's say if we want to test the input 1 and then the second input I want to test 4. So in this case, I want to test 1 bits and 4. What's the result? Then this is the way to do it. Oh, sorry, I forgot to. Oh, sorry, there's a typo. It's a b-test. Here, yeah, again, so this taking the input 1 and 4, the result should be 0, but if it is getting 1, so this total this test case is still failed here. This is a way for us to test with the specific inputs that we want. Again, this b-test is the one that to help us test the logical correctness of the solution. Later on, we're gonna use both the b-test and DLC to check our solutions. With that, we are ready to go to the coding session. See you in the next video.